All right, so last section we're going to look at is 7.4. In section 7.4, it's really a summary of everything that we've learned this week. So we're going to be changing between log and exponential form. So we're going to have to do that. We might use some properties of logarithms to either take two logs and combine them together or split them apart. Change a base formula might come up. And then any techniques you'd use in algebra, because that's basically what this is. It's solving equations. So something that might come up in algebra would be like a quadratic formula. All right. So let's see if we can solve this. It says 2 log base 5x equals log base 5, 9. Well, there's something that it's going to help us because it already matches. Right? That's what equals means. You want what's on the left to match what's on the right. What already matches? The base. Okay, if the base didn't match, this would be a lot harder problem. So, since the bases match, that's good. All we have to do is make the arguments match. Now, the argument on the right is fine, but the argument on the left is not really x. What would the argument on the left be if you use the property we learned yesterday? Yep.
Log the base 5x squared.
Right, it's really x squared because you can put the 2 in the front. So first thing you want to do on a problem like this is put the 2 back as an exponent. Now, this already matches that. So that's good. We just need to make this match that. So all you have to do at this point is find a number you could plug in for x, so that if you fill it in for the argument on the left, it would come out to the same as the number on the right. So what could we fill in for x? Yeah? X could equal 3. Yeah. And that's it. That's the answer to that one. So if you fill 3 in, you're going to get 9. And then you'd have log base 5, 9 on the left. Log base 5, 9 on the right. Any questions on that one? So not really a lot to that one. Let's try this one. So it says log base 4 of x plus 3 plus another log base 4 of 2 minus x equals 1. Okay, the first step in this kind of problem is going to be to eventually get rid of all the logs. Okay, that's the goal. So once we turn this into a problem without logarithms, it's going to be algebra from there. Okay, so look at the logs on the left-hand side. Does anybody notice anything about both of them? They both have a base of 4. So when you have 2 logs, and they both have the same base, you can take the 2 logs that are separate and do what with them? Well, yeah, we're going to combine them. And then whether we multiply or divide, we'll talk about that next. We're going to combine them into a single log. All right, so we had 2 logs that are being added. How do you combine the 2 arguments to a log when there's an addition sign? Yep, you're going to multiply them. So you put your first argument times your second argument. And that's still equal to 1. Okay, now we need to do this out. Sometimes people remember how to do this, like there's a certain order they follow. Does anybody know the word I'm thinking of? When you multiply 2 sets of parentheses together? Yeah, distributive property is another word some people use. FOIL. That means you multiply first, outer, inner, last. But double distributive property is the same. So let's do all that. All right, when I multiply this out, Austin, what's x times 2?
2x.
2x. And Alex, what about x times negative x?
Negative x squared.
Okay, so we got that. Curtis, what about 2 times 3? 6. And then Tony, 3 times negative x.
Negative 3x.
Negative 3x. Okay, so now that we did that, we've got some more things we can combine together. Cameron, what can I combine together inside the parentheses there?
The 2x and negative 3x.
Yep, the 2x and the negative 3x. The other thing I'm going to do is I'm going to start to write this in the normal way you see it when you do a quadratic, because that's what this is turning into. So I'm going to put the x squared first, and then 2x minus 3x.
Negative x.
Yep, and negative x plus 6. Okay, so we've combined everything together in a single log. What can we do with that now? Something we learned on Monday. First thing we learned how to do with the log equations. Yep. Turn it to an exponential. So remember, when you change it to exponential, you're looking for 3 things. That's 1. That's 2. That's 3. So we need to put those 3 things in the correct spots. Let's start.
Yes.
That's the pattern we're looking for. Let's start with this box. Sam, what's going to go in this box?
The base.
That's the base. And what's the base in my log problem?
4.
4. So 4 is the base. And theoretical logarithm always equals what kind of number?
An exponent.
Logarithm always equals the exponent. Okay, so we got that. And the only thing we have left is what ends up by itself. And 1, what do we call the thing that ends up by itself? The argument. And that's negative x squared minus x plus 6. Perfect. So now, at this point, we've gotten rid of the log. So that everything I taught you is done. From here, you need to solve it with what you know from algebra. So that's a quadratic. What do we generally want to get a quadratic equal to if we're trying to solve it? Doesn't matter if you can factor it or use quadratic formula. You've got to get it equal to what number?
0.
0. I would move everything to the left. You might be saying, well, why not just put the 4 on the right? Well, it's because of that. If I'm going to solve this with factoring a quadratic formula, I would rather have this positive, and I can make it positive if I put it on this side. All right, so let's do that. So we're going to add the x squared. That's going to move that to the left. We're going to add the x. It's going to move that to the left. And how am I going to put 6 on the other side? I'm going to subtract. So now I have nothing. We moved everything to the left side. And 4 minus 6 is negative 2. Any questions so far? Okay, now we have to try to solve it. Well, one way you can try is factoring, but factoring will not work here. Because you'd have to find 2 numbers that multiply to give you 2. Negative 2. And then they have to add or subtract to give you 1. You can't do that. You can't find 2 numbers that multiply to give you negative 2 and add or subtract to give you positive 1. Think about if you tried. You know, when and last term is a negative, your signs have to be one of each. And if you try, let's see, could we try? actually, hold on, let's see if this works. Is that factorable? So if we check that, x times x is x squared. X times negative 1 is that. X times 2 is that. And what's negative x plus 2x? X. And what's 2 times negative 1? Negative 2. So it was factorable. Okay. So we didn't need quadratic formula. So it's like worth just giving it a shot. If you can factor it, that's usually a lot faster. All right. So now we've got something times something gives me 0. What's the only way you can multiply two things together and get 0 for the answer?
One of them has to equal 0.
One or both of them have to equal 0. So what would you plug in for x to make that 0?
Negative 2.
Negative 2. And what would you plug in for x to make that 0?
1.
1. Now, the only thing we have to be careful with logarithms is we don't take the log of a negative. Because we talked about what happens if you try to do that. You end up with an imaginary answer. So we need to check and make sure that if we plug in these numbers, we are never taking the log of a negative. Let's check 1. What's 1 plus 3? 4. That's log base 4 of 4. That's fine. This came out positive. What if we plug in 1 here? What's 2 minus 1? 1. So that's okay too. So plugging in 1 works. Let's try negative 2. Ryan, what's negative 2 plus 3?
1.
1, so that's a positive number, that's fine. And what's 2 minus negative 2?
Negative 4.
That'd be 2 minus 2.
Oh, 4.
4. So when you plug these numbers back in, you never end up with a negative here or here, which means both of the answers work. So they're both good. 3 things can happen when you solve a problem like that. Either both answers work, one answer works, one answer doesn't, or both answers do not work. If you get an answer where they both don't work and there's no solution, you might see this symbol as the answer. It's a Norwegian letter, but they use it in math to represent no solution. Right, but in this case, there is definitely a solution, and there's 2 of them. Okay, we'll try another quadratic at the end, maybe where one answer works, one answer doesn't. Any questions on that one? So originally, I thought that was when we were going to need quadratic formula, but we didn't end up using it. Okay, and this is what I just mentioned to you. Always check your answers to make sure you are not taking the log of a negative number. If that happens, cross that answer out. Okay, let's try this one. So that one's definitely a little bit easier than the last one. There's only one thing you can do with that. Tyler, what can we do with that equation? Yep, change it to exponential form. That's the only thing we can do. It's not like you have separate logs you can try to combine together. You don't have numbers in front you need to put back as exponents. You don't have any of that. So let's just change it to exponential. Gavin, when I change it to exponential, can you tell me what I get?
Let's see.
Remember to change it. There's no math here. It's either we have the formula to do it or we don't. So you have to know where those three things are going to move to. Well, let's start with this. What is this called? You want to help them out? What's that number called? That's lower 3. That's my base. So when I rewrite this as an exponential, 3 is going to be my base. Okay, so 3 is my base. Logarithm always equals what kind of number? Exponent. So in this case, my logarithm equals what number? Am I asking really hard questions? Or are we just a little tired today?
9.
Okay, 9. Yeah, what number does the logarithm equal? Logarithm equals the number 9. So logarithm equals your exponent. And what ends up on the other side by itself? X. So just by writing it in exponential form, you basically have your answer. That's the easiest one I think we're going to do today. Depending how big the number comes out on the left side, I may or may not do that on the calculator. 3 to the 9th is a big number, but it's not huge. So we'll probably do it out. Sorry. 3 to the 9th. 19,683. So that's small enough. I would ask you to do that out on a test. What would be something that's too big? Something that's in like the hundreds of billions. That's getting too big. 19,000, that's small enough to do that. Any questions on that one? All right, let's try this one. This is very similar to the first kind of problem I showed you at the beginning of the week. It's the whole reason we use logarithms, just to try to figure out what power you could raise something to get another number. So I want to know what power I can raise the number 2 to get 5. Well, it's not 2 to the second, that's 4. It's not 2 to the third, because that's 8. So it's somewhere in between the two. Jenna, what can I do with something like that? Yeah, let's change it into log form. That's really the only thing that we could even try with something like that. Okay, we're going to change it to log form. What's the first thing I have to write down?
Log.
Yep, I need log. Without log, I don't even know what it is. So log means it's in log form. And now we need 3 things. Logarithm always equals what kind of number? Or what kind of thing?
The exponent.
The exponent. What's my exponent in this case? X. All right. What's going to be the base on my log? 2, because that's the base on the exponential. And what's going to go right here? The argument. What was all by itself on the other side. So that's my argument. So now I just need to figure that out. The problem is the calculator can only do what bases? By pressing a button. Yeah, you can only press a single button to get an answer if it's base 10 or base E. So how am I going to rewrite that so I can type it on the calculator? Yeah.
Log base 5 over log base 2.
Well, we don't have base 5 or base 2 buttons on the calculator. Yeah, so this really is base 10. Log 5 over log 2. You could also do another thing that we talked about, instead of log 5 over log 2, how else could you write it?
ln.
You could do ln 5 over ln 2. But don't mix them. Pick one or the other for the problem and just use that. So let's do log 5 divided by log 2. Does everybody agree with that?
No,
No? Why?
you didn't put the parentheses on log 5.
I didn't close the parenthesis. That's going to come out wrong. It's not even close to right. It's just completely different. So that's the correct answer. 2.322. 2.322. So I'm probably going to ask on the test for at least 3 or 4 decimal places for those kinds of problems. And there's no reason, since that's the calculation, there's no reason why you shouldn't be able to be accurate to 3 or 4 decimal places. Any question on that one? And nice thing, if you want to check it, take that number and plug it in. See if you raise 2 to the 2.322 power, if you get 5. Or, because we rounded it, you might get like 5.0001 or something like that. But it'll be pretty close. Right. 3 to the x equals 24. Let's just kind of think about what the answer should be between. 3 to what power is smaller than 24? 3 to the what?
Second.
3 to the second. That's too small. That only gives me 9. And 3 to what power is too big? 3 to the third. That gives me 27. So the answer to this is going to be somewhere between 2 and 3. Let's see what we get. Naija, what could I do on this one?
You can do log base 3 and then 0.74.
So log base 3 of 24, yep. And one more thing that we have. Yeah, equals x. So log base 3 of 24. And Sam, can you tell me how I type that in?
It would be log 24 over log 3.
Is it okay to flip it? Could you put the log 3 on top?
No.
No. If you flip it, it's going to come out wrong. Let's do log 24. Again, make sure you close the parenthesis. Divided by log 3. It doesn't matter if I close the last one because I'm done. There was nothing else. Okay, so 2.893, and that's exactly what we said it should be between 2.2 and 3. Any question on that? Alright, let's try this one. It's pretty similar to the last two. There's just an extra step you need to do first. So it says 8 times 3 to the x equals 5. 1, what could I do first there? And once we do this, it's going to make it exactly like the last two problems. Well, we do want to do that eventually, but there's something I need to do first. Because to be in, this is not quite exponential form. It would have to look like this. what we have right now essentially looks like this. That's not quite exponential form, but we can make this look like that.
2128.
Pem dash, you can't do that because that's raised to a power, so you can't multiply these. They're not like terms. 8 and 3. Anybody see what else you can try to do? No?
You divide 8 by both sides.
Yep, exactly. You can divide both sides by 8. That easy. And now we have a problem exactly like the last two.
I'm supposed to get dismissed.
Oh, okay. Yeah, thank you. So 3 to the x equals 5/8. Now let's do what Juan said and change it to log form. So Dominic, what's my base?
3.
All right. And Austin, what's the logarithm going to equal?
X.
Yep. Logarithm always equals your exponent. And Alex, what's going to be on the other side?
5/8.
5/8 is my argument. Alright, let's type that in. Hopefully by now we know how to type in when it's not base 10 or 8. Log of the argument. Log of 5/8 divided by log 3. We get about negative 0.428. Negative 0.428. And we've talked about what happens when your exponent comes out negative. It causes it to flip. Look at the original problem. The original problem was finding a fraction. When you're trying to raise something to a power, and you want it to come out to a fraction where the number in the bottom is bigger, a lot of times the exponent has to be negative to make that happen. It flips it. Question? All right. Let's try this one. And this one I'm just going to talk a little bit about. It looks kind of like one we did before, but there's something very different about it. Does anybody see what's different? And this is what I want you to notice. I don't really want to solve it. I just want you to notice this and realize you can't do what some people might think you can do. Yeah?
Bases are different.
The bases are different. So you are not allowed to combine these two logs together. So bases are different. So we cannot combine the logs. Doesn't mean you can't do it. You can definitely still do it. You just can't do it by combining the logs together in a relatively quick way. So still doable. It's just not really something we're going to look at, but I want you to notice you can't do it the way you might think you could because the bases are different. But definitely still doable with algebra. I know how to do that with algebra. This one is another one that would be hard to do. Because remember, the goal is to get x by itself. Well, if all you had was this, then yeah, we could deal with that. That's exponential form. Change it to log form. And then we could go from there. This problem would be exactly like one of these problems. Something to a letter equals a number. Something to a letter equals a number. What complicates it is this. Putting that plus x in front. So as far as using algebra to solve that one, that I don't know how to do. Because you can't get the x by itself. Or if you didn't have this x, then it wouldn't be a problem either. So that's easy. Just minus e from both sides and then we're done. Having both those x's is a problem. So how could we use the graphing calculator to solve a problem like that, since we don't know how to do it with algebra? Thoughts? Yeah.
Can we plot it?
Okay. So tell me how we would do that.
So I would subtract the x from the left side, making it 2 minus x. And then I would plot e to the power of x.
So you just do it like this. Okay. And then you said you would graph e to the power of x?
Yeah.
All right, so we can type in e to the power of x.
And
Oh.
y2 and graph 2 minus x and then find the intersection.
Yep, exactly. So you can find the intersection. You could have also done it the way it was written. You could have put this in y1, and you could have put that in y2. But the idea is you need to put the left side in y1, put the right side in y2, and then let's graph it. And it's exactly what Alex said. We're looking for the intersection. Now you can just wait for Curtis in there. Yeah, come on in. Okay, so we graph those 2 points, and how do we find where they cross? We did this much earlier. We could do trace, but we don't want to try to guess where it crosses. We want the calculator to give it to us exact. Yep. Yep. So second, calc. Should be. There it is. Intersect, and then we hit enter 3 times. And without that much work, we get an answer to a problem that we can't really do by hand. At least with relatively simple algebra. So graphing is always a way you can solve something if you can't solve it without. Any question on that one? All right, I think this is it, last one. So let's try one. This is a little bit more of what we are used to doing. Because what do you notice about the 2 logs? Yeah, they have the same base. We're going to be able to do something that we did. I think this is very similar to example 2. It's almost the same kind of problem. Right, look at that one, and then look at example 2. It's pretty much the same idea. Okay, so what? Now that we've gone through it together, you tell me, what would I do first here?
Combine the logs.
Yeah, combine the logs. When you combine them, what type of log or what's the base we're going to have on the log?
4.
It's going to be 4. And when you say combine them, what are the 2 things I'm going to combine, and how am I going to do it?
You're going to multiply x times x minus 3.
I'll multiply x and x minus 3. It's actually a little easier than the problem we did because that's not even a double distributive. That's just a single distributive. It's going to make it easier. And that's still equal to 1. Okay, now you want to do what's in the parentheses. What do you get when you multiply out what's inside the parentheses? X squared minus 3x. Okay, so as far as using rules of logarithms, those are all done. We've done as much as we can with logs. what do we have to do with that now?
Turn it into exponential.
Change it to exponential. Yep. Tony, what's my base?
4.
Yep, 4. And 1 logarithm always equals what kind of number? Exponent. So logarithm equals, my exponent is a 1. And Gavin, what goes on the other side?
Would it be x squared minus 3x?
X squared minus 3x. So that's a quadratic type of equation. So we're going to try to get a certain number on the other side. Ryan, what do we want to get by itself? Or what number do we want on one side by itself? 0. How would you get 0 in this one?
Add the 3x. And, well, let me subtract 4.
I just subtract the 4, yeah, because the x squared is already positive. We don't really want to mess with that. So bring the 4 to the other side. All right. And what's one way we can try to solve a quadratic? This way is faster if it works. All right, let's try to factor it again. 0. Okay, if I'm going to factor it, Jackson, what would be my first term in each parenthesis?
Just x.
Yep, just x. Because x times x has to give me x squared. I have a negative middle term and a negative constant. So what does that mean about my signs in the parentheses? Positives, negatives, or one of each?
Negatives.
Well, if you put a negative and a negative, then a negative times a negative would give you a positive. So yeah, you're going to need one of each. And we need 2 numbers that multiply to give me 4 and subtract to give me 3. Four and 1. You want to put them in that order, or do you want to do 1 and 4?
Try 1 and 4.
Let's try 1 and 4. Okay. What's x times negative 4? Negative 4x. And what's 1 times x? And what do you get when you add those up? Negative what? Negative 3x. And that's what I was trying to make sure I got in the middle. Okay, so we factored it correctly. So when we solve a quadratic, generally we're going to be looking for 2 answers. What's going to be my first answer? Yeah.
-1.
It's going to be -1. Because if you plug -1 in, you get 0. And 0 times anything is 0. Now I need to figure out my second answer. That's right, yeah. That's going to be 4. Now, those are the 2 answers, but we always want to make sure that we don't do what? With either one of those answers. Yep.
Does it have a negative?
Well, we want to make sure we don't want to take a log of a negative. It's okay if you have a negative number, but when you plug it back into the problem, you do not want it to be a log of a negative. Let's check 4. If I plug 4 in for x, does what I just circled come out positive? Sam? Yeah. What if I plug in 4 for x there? Does that come out positive? Right?
No.
No, what's it come out to?
Oh, wait, yeah. 1.
1, yeah. 4 minus 3. So that comes out positive. So this one's fine. Let's try -1. If I plug in -1 right there, does it come out positive? Is that it? No. It doesn't even matter if it comes out positive here. It doesn't. It comes out to -4. So what that means is the -1 answer does not work. We need to cross it. So we did one type of problem like that where they both work, and I just showed you one where one works and one doesn't. It's possible you get ones that don't work. All of them, across them both. And what symbol might you see if all your answers disappear? Yeah?
You know, it crossed out.
Yeah, you see like a circle with a horizontal, like a diagonal line to it. Yep. But you wouldn't see that on this problem? Well, if it was a multiple choice question and you saw that as an answer, that's wrong. Because this one has an answer. Just one answer. Okay. Any questions on? Alright. So what I'm going to do, I'll put up the homework. You've got about 20 minutes or so to start that. I'm going to put a list of topics that are going to be on the test for tomorrow. And reminder, I will be after school today. If anybody needs to see me about getting any work made up or need some help with stuff before the test.